Hello guys, have you done part one yet or not yet? It shouldn't be too difficult for you guys. All right, here we are. So let me show you how to do. Let me show you how to do part one. Let me know if the focus is not clear. Please let me know. Okay. So the question is to find the cumulative distribution function of the most expensive asset. So you're looking for the probability that capital X is less than equal to little x, right? It is the probability that the maximum of x1 to x alpha is less than equal to little x, right? All right. Now, if the maximum is less than equal to this, then each of the individual variables has to be less than equal to that. Okay. But there's now, because we are assuming these are independent variables, so using independence, we can write this as the probability that x1 is less than equal to x up to the probability that x alpha is less than equal to x. Now we are assuming that each of these is a exponential random variable with parameter lambda. So this guy is the CDF of exponential with parameter lambda, which I'm sure you guys know is equal to this. You should know that this is the CDF of an exponential with parameter lambda. And the same thing over here. Okay, so you have the same thing repeated alpha times. So the answer is to the power alpha. So this is the answer to part one of the tutorial sheet. Part two is to find the PDF of X, right? And I'm sure you know to find the PDF, all you have to do is to differentiate the CDF with respect to differentiate the CDF with respect to X. So we should differentiate this with respect to X. This is what you will get. You will get alpha lambda e minus lambda x right to the power alpha minus 1, right? So this is this is what you get. So that completes the second part of the question of the tutorial. The third part is to find part 3 is to find the nth moment. When I say the nth moment, I think I might have explained this, or maybe not, I don't know. In either case, I will the nth moment of X is basically the expected value of X power n. This is what I mean by the nth moment of X, right? So this will be the integral from 0 to infinity of yeah, okay, and now you substitute this into this, right? This is what you will get. You get alpha lambda times the integral, which is from 0 to n, sorry, 0 to infinity, I mean 0 to infinity of x to the power n ef minus lambda x 1 minus 1 minus this to the power alpha minus 1 dx. All right. Now, what I like you to do is, I mean, instead of me doing all the questions, I would like you to work out this. I will give you like about 5 minutes or so and see if you can work out this integration by yourself. I mean, I can, obviously I can do it, but no point me doing all the questions. So please take about 5 minutes or so to see if you can calculate this integral. It uses some stuff that I taught you before in the preliminary section. Remember that there are 4 or 5 videos I did on the preliminary section of the YouTube channel. I hope you guys watched those videos earlier. So you should have watched those videos. You should be able to work out this integral. So please try and see if you can do it. All right, I take about 3 or 4 minutes. All right, after that I'll show you how to do it. If you're just joining us, we are doing part three of the tutorial sheet for week 4. All right, guys, have you done this? So to work out this integral, I mean, using the videos I did in the preliminary section of the YouTube channel or the course website, you should be able to work out this integral. Okay. So, right, so it's not, All right, so if you haven't done it, let me show you. All right, so what I'm going to do is I'm going to make a substitution. I'm going to say set y equal to e minus lambda x, right? Which implies that x is equal to minus 1 over lambda times log of y, and which implies that dx by dy is equal to minus 1 divided by lambda y. All right. Now let me put this in the box. I'm sure you've seen a lot of boxes in my course. Okay. All right. Right now, so after making this substitution, let me excuse me, just give me a sec. So after making this substitution, you will get the following. You get alpha, lambda outside. The limits of integration, when x is 0, y will become 1. And when x is infinity, y will become 0, right? And inside you will have the following. Okay, this is what you will have. Okay, you follow what I've done. Okay, all right. Now I'm gonna use this negative sign here to change the limits around from 1 to 0 to 0 to 1. And also, as you can see, quite a few things cancel. For example, the y here and the y here cancel out. And you can combine the lambda here and the lambda here. Actually, the lambda here and the lambda here cancel out, right? So what you will get, let me put this away. What you will get is the following. You will get alpha minus 1 power n divided by this. Then the integral from 0 to 1 of right. Now, in the next step, I'm going to use a property I mentioned in the preliminary section of the YouTube channel or the course website, which is this one. I think you should remember this if you watched all my videos. That log of y raised to the power n can be written as this. This is one of the I did a video on this trick, which I call a differentiation trick, right? So what I'm gonna do is to replace this guy here by this guy here, right? So you will get right? Uh, this whole thing multiplied by, okay, all right. And in the next step, I'm going to take the derivative operation outside the integral, right? And also I'm going to take the set beta equal to 0 outside, right? So you will get the following. You will get the following. You get, so the derivative operation applies to the integral from 0 to 1 of y power beta 1 minus y power alpha minus 1 dy, and then set at beta equal to 0, right? All right. Now, this is where another thing that I taught you guys in the preliminary section of the YouTube video that comes in, or the I think you should remember this. If you have looked at all my videos, one of the things I talked about is the beta function. The beta function at a comma b is defined as the integral from 0 to 1 of this. Right. I actually did a video on the beta function. If you did not watch it, please go back and watch it. It's in the course website and also in the YouTube channel, right? Okay. So using this definition, and because this is of this form, you can replace this by a beta function. So what you get is the following. So according to this definition, what you have here is a beta function at a equal to beta plus 1, and your b equal to alpha. All right. Okay. So that completes part 3 of the tutorial sheet. So this is the answer I expected you guys to get. Now part 4. Part 4 is to find the mean, and the mean of x, right, which is basically the expected value of x, right? The expectation of x is what you get here if you put n equal to 1. So if you put n equal to 1 into this formula here, you will get the following. This is what you get, right? Now if you go back to the video I did on the beta function, the beta function has several properties, and one of the properties I mentioned in the video is the following, that this can be written as follows. All right. I mean, this is one of the properties I talked about in the if you haven't watched the video, please go. It's in the channel, YouTube channel, and also on the course website that I did a video on the beta function, and this is one of the properties I mentioned. Okay, now to do this differentiation is easy because all you have to do is the quotient rule. I'm sure all of you know the quotient rule for differentiation. You have this a function involving beta, which is this term, and another function involving beta, which is this term. So if you do the quotient rule for differentiation, which I'm sure all of you learned that in your first year, long time ago, right? This is what you will get. I'm not going to show you the details, but you should differentiate this using the quotient rule and then put beta equal to 0. You will get the following. Correct me if I'm wrong. I mean, it's possible that I might have made a mistake or so, but yeah, but this is what I get. All right, so this is the answer. This is the answer to part 4 of the tutorial sheet. Right, any questions on this, guys, please? Hello, guys. You're keeping quiet today, guys. Anything not clear so far? Let me just use the chat box or talk to me using your microphone. Are you okay? Okay, thanks. So everything okay so far? So that's part 4. Now part 5 of the tutorial sheet is asking you to find the variance of X. Remember, X is the most expensive asset. All right, so I'll show you how to do that. So here we are. So this is part 5 of the tutorial sheet. You want to find the variance of X, right? Which I'm sure you know is the expectation of X squared minus the square of the expectation. Okay. Now this guy here, from what we did earlier, right? To find the expectation of X squared, what all you need to do is to put n equal to 2 into this. This is the formula for the nth moment. So to find the second moment, all you need to do is put n equal to 2, right? So that's what I'm going to do now. So put n equal to 2. So this becomes minus alpha divided by lambda squared. The second derivative with respect to beta of right. Okay. All right. Okay, guys. Now I'm gonna use the same result as I did in the previous part. Now this one, according to the video I did, can be written as This is one of the properties of a beta function, right? Okay. So now here, to do the differentiation, you need to use the quotient rule 2 times, right? First with respect to beta, and another time with respect to beta, all right? So it will be, I mean, it will be messy, but it's kind of routine. I'm sure you guys done differentiation quotient rule, using this quotient rule many times, so it shouldn't be a problem. But if you do the calculations, after a while, this is what you will get, I think. Correct me again if I'm wrong. So I'm differentiating this 2 times with respect to beta, and then putting beta equal to 0, right? Right, then plus, all right, so close bracket minus the square of the expectation, which we worked out in the previous part, right? All right, so this completes part 5. Oh, I got a question from Patrick. Variance, Patrick, the variance is given by this. The variance is the second moment minus the square of the first moment. So that's what I'm using. And the second moment is given by this formula here, right? This is the formula for the second moment, right? And so I think this should be a plus. I think I made a mistake. Thank you. This should be, yeah, the second moment is given by this with the minus the square of this first moment, right? And that's what I have done throughout, Patrick. So yeah, I think there should be a plus here throughout. So plus, plus, plus. Okay, so that, because you see, remember, I'm using this is the formula for the nth moment. So if you put n equal to 2, minus 1 power 2 is a plus number. Okay, all right. Okay. All right, guys. Now the next, so that's question 5, part 5 of part 6. You won't be able to do yet. Part you won't be able to do, and this also part 7 also you won't be able to do. So can you go to the last part, which is part 8? Can you do part 8 of the tutorial sheet, which is the last part? I'll give you a few minutes and see if you can do it. Just to make the question clearer, I should have said, I should have said in the question, suppose or supposing. mm, All right. So I think the question is not very clear. So just to make it clearer, the part 8 should have read like this. It should read like, supposing that you have a random sample on X, where X represents the most expensive asset. Find the MLEs of alpha and lambda. Okay. You guys okay? All right. So the first thing you must write down is to. I'm sure all of you know what MLE means. I'm sure. So the first thing you must do is to write down the likelihood, the likelihood function for the two parameters. Right, and so this is gonna be the product I from 1 to n of the density function, which we worked out earlier. So you may recall this is the formula for the density function. Right. So we derived this in part 2 of this tutorial sheet. So if you take the product of this, you will get the following. All right, so this is the likelihood function, and the next step is to take the log of the likelihood function. So you take the log of the likelihood, you get n log alpha plus n log lambda minus lambda times the sum of xi, yeah, plus alpha minus 1, excuse me, alpha minus 1 times the sum of log of 1 minus, okay. So this is the log likelihood. And the next thing to do is to take the partial derivatives with respect to the two parameters alpha and lambda. So that's what I'm going to do. So the partial derivatives with respect to WRT, alpha, and lambda are. So let's first look at the partial derivative with respect to alpha. So this is n over alpha plus all right. So this is the partial derivative with respect to lambda. Correct me if I'm wrong. And the partial derivative with respect to lambda. Okay. All right. So just once again, check if my calculations are correct. Right now, to solve these two equations for alpha and lambda, we need to set this to 0. We need to set this to 0. Let's call this equation 1, and let's call this equation 2, right? Now, from equation 1, you can see that you can express alpha hat, the MLE for alpha, as in terms of the following. Okay, so you can express alpha hat in terms of lambda hat. That's using from equation 1, right? And let me call this equation 3, right? Okay, now excuse me. So here we are. Okay, so now what I'm going to do next is I'm going to substitute substitute 3 into 2. Now if you do that, so if you substitute 3, which gives an expression for alpha hat in terms of lambda hat, into equation 2, which is this one, this is what you will get, unless I made a mistake. You will get the following. You will get n divided by lambda hat minus the sum of xi minus brackets n divided by right, plus 1 close bracket, then sum 1 to n. Sorry, this is a messy equation. Sorry about it. Of xi okay, right, equal to 0. All right. So you should, let me call this. I hope you can see this. Can you see it, guys? Yes. Let me call this equation equation 4. Now, if you look at equation 4, you will see that there's only one unknown parameter in equation 4, namely lambda hat. Okay. All right. So you can easily solve equation 4 to obtain a solution for lambda hat. All right. So what I'm going to say is the following, just to complete this part. Solve excuse me, solve equation 4 to get lambda hat, right? Okay, and then once you got lambda hat, use equation 3, because equation 3 over here gives you alpha hat in terms of lambda hat. So once you got the solution for lambda hat, or you can sub it into equation 3 to obtain alpha hat. All right, so that completes the final part of this tutorial sheet. You have any questions on this, guys? I mean, any questions? So the only thing that involves that's really difficult here is to solving this equation, which can be done easily using a computer program. So once you got your lambda hat from this equation, sub it in here, you would get alpha hat. All right, guys, so this completes the tutorial sheet for this week. Any questions you guys have, or anything that you'd like to talk about the course? Just to remind you that the next quiz is quiz number 3, which is due next Tuesday. Quiz 3 is a little bit trickier than the previous ones, but the level of mathematics is not difficult. I mean, it's not something you haven't learned in your first year undergraduate degree. So it's not really difficult. You should think about it. But if you need any help, just contact me. I can only give you limited help because, as you know, this is assessment. So, but try to do it by yourself. And as I said, it's not a difficult one, but it's more difficult than the previous 2 quizzes, right? Okay. All right, guys. Any questions you want to ask me now? You okay, guys? Hmm? Yeah. So next week we will talk about case 5 and 6 of portfolio theory, right? Okay. All right, guys. If you have no more questions, please let's bring this to a close today. And I will talk to you whenever you want to talk to me. Just please feel free to talk to me 24/7 by any means, by phone, by email, by Skype, or by Zoom. All right, take care, guys. Bye.